Hello everyone, I welcome you all to the next part, and today we would be starting with a question. So far we have discussed all the types of quadrilateral along with the properties of a parallelogram. Okay, so we have seen some questions too, but this question is a little tricky, so we will be starting with that. First of all, just read out the question with me, pause me out and try it by yourself first. Okay, so what things are given to you? Two lines parallel are given to you, L and M, and they are intersected by a transversal P, correct? And we have to show that the bisectors of the alternate interior angles of is forming a rectangle, correct? So how we would show that? Now, what things are given to you? Firstly, write it down, okay? So basically, you are given with this is the angle bisector. So I'm just naming out the angle. Okay. Someone may ask why you always name it one because it's easy to write. Okay. Now every time I have to write PAB rather than I can denote it with angle one. Correct? Okay. Never mind. This is angle 3. This is angle 4. Similar fashion 5 and this is angle 6. This is angle 7 and this is angle 8. Why I'm giving it a same sign? Because they are bisectors. It's written right, bisectors. So they are divided into half. Correct. No. Now, just tell me if PS is parallel to, which is L is parallel to M and P is traversal. So this whole angle would be equal to this whole angle. Why? Because of the angle interior opposite of a parallel lines. Now, we know that they are equal to each other too. So, we can state that angle 2 is equal to angle 5. Correct? And from this conclusion, we can say that AB is parallel to CD. Taking same P traversal. So, it's concluding AB is parallel to CD. It's also concluding BC is parallel to AD because it's acting as an alternate angle for them. So, it's also concluding BC is parallel to AD. So, this both conclude that ABCD is a parallelogram. So, this is a short form of writing parallelogram, correct? Okay. Now, we have to show that rectangle, how the parallelogram drives to rectangle. Like, what is the property? The property says that one angle is 90 degrees. So, obviously, all the angles will be 90 degrees. So, let's show that. Okay. We also know that angle 1 plus angle 2 plus angle 3 plus angle 4 is linear, so 180 degree. Now 3, 4 are equal, 1 and 2 are equal. So in short, we can half it out and say that angle 2 plus angle 3 is 90 degree. Correct? Now what it states? It states BAD is 90 degree, which means this parallelogram has a 90 degree angle in it. So this both concludes that ABCD is a rectangle. I hope you know how I drive the conclusion. Correct? Okay. Next question. Show that the bisectors of angles of a parallelogram form a triangle. Okay. So they are bisectors of angle, which means that this both angles are equal to each other. Okay. They are bisectors and they bisectors coincide at certain points. So we have to show that they form a rectangle. Okay. Again, pause me out and try it by yourself first. Then we would discuss. Okay, now you all know what the first thing I would do. Just start naming 1, 2, and suppose I name it 3 and 4. We only need this, correct? We firstly know that angle 1 plus angle 2 plus angle 3 equal to 180 degree. I hope you know that, correct? And you also know that angle 3 is equal to angle 4, vertically opposite angles, correct? Now, just see, this whole angle is equal to this whole angle. How? Are they equal? No. I was just bringing your attention on tables. They are not equal. They are bisectors. So this is equal to this and this is equal to this. But their sum is 180 degree. How? Because I'm just writing this too. So angle 1 plus angle 5. That means the whole angle plus angle 2 plus angle 6 is equal to 180 degree because they are alternate. They are interior angle supplements of AB is parallel to CD being AD transversal. Correct? So we'll half it out and we'll draw to the conclusion that this is equal to what? 90 degree. Now just put this equation here and you will find angle 3 equals to 90 degree. which is equal to angle 4. So similar fashion, you can find that every angle of this PQRS is 90 degree. Correct? Now, since angle I will name it 7, 4 is equal to 7 and also 8 and 9. This P and R, angle P is equal to angle R. So this implies PQRS is a parallelogram because opposite sides are equal. And being one angle 90 degree, it states that it's a rectangle. I hope you know how I write the solution. Okay. So this question were a little tricky, but they were part of your evaluation. Now we'll go forward with the properties of parallelogram. So what does parallelogram states? A quadrilateral is a parallelogram if pair of opposite sides is equal and parallel. Correct? So they are parallelogram. ABCD is a parallelogram in which P and Q are midpoint of opposite sides AB and CD. Midpoints means that CQ, okay, we'll mark it out here. This equal to this and this equal to this. Correct? If AQ intersects DP at S, A and Q intersect DP at S, and similar fashion at R, show that APCQ, A, P, C and Q means this. This is a parallelogram. Okay. We know that AB is parallel to CD. So if we'll half it out also, then they are parallel to each other. So we have shown that AP is parallel to CQ. Like it's obvious. Now we just need to prove that AQ is parallel to CP. And we'll arrive at a solution. Now think of an angle which proves the same. Which proves you that they both are equal. Correct? So just think how you'll think. Take this angle and this angle. Or take this angle and this angle. Okay, cool. So this line and this line already parallel, so they would be equal. So we'll just name it same. I'm just doing another naming to make you understand. So 1 and 1, 3 and 3. Correct? Now, this angles would be 180 degree. How? Because this and this lines we need to prove them equal. Correct? Also, you can see that we have just learned the property that opposite sides of parallelogram are equal. Correct? So, AB would be equal to CD. If AB is equal to CD, then half of AB is also equal to half of CD, which means that this line is also, CQ is also equal to AP, and similarly DQ is also equal to PB. Correct? So, they all four are equal. So, if in a parallelogram opposite sides are parallel and equal, then it is a parallelogram. So, they both are parallelogram. Okay, I hope you understand how I concluded both the terms. Correct? Now, from above solution, we can state that DQ is parallel to PB. Correct? And DP is parallel to QB. So, parallel lines are not mandatory that their length is fixed. Correct? So, this line is also parallel to this line, which implies that SP is parallel to QR. And in similar fashion, SQ is also parallel to PR. So, they both implies that PQRS is a parallelogram. Correct? Because both the opposite sides are parallel to each other. Correct? Now, we will start with midpoint theorem. What is midpoint theorem? It states that the line segment joining the midpoint of two sides of a triangle is parallel to the third side. Means that EF is parallel to BC. Okay? Now, how do we prove that? It's shown that EF is extended till D and a line is drawn from CD. Okay, the line drawn to the parallel point parallel to another bisects the third side. Okay, so line drawn through the midpoint of one side of a triangle means that any line like like L is drawn. Okay, so E is the midpoint of AB and L is parallel to BA. Correct? So F is the midpoint of AC. This is just the extended way. Now, we have to solve this question in ABCD. D, E, F are respectively the midpoint of AB, BC and CM. Show that triangle ABC is divided into four congruent triangles by joining DE, EE and EF. Correct? Now, pause me out and try it out. For this question, I'll like you to solve it out. Okay? Because it's really easy question. Okay? I'll just show you ahead. See that D's midpoint means that this both are equal, this both are equal and this both are equal. Okay, also shown that by midpoint theorem, which we have just read, I'm just doing it for a part, okay? DF is parallel to BC. So if DF is parallel to BC, it would also be parallel to a midpoint, which means that DF would be parallel to BE, correct? Now, in a similar fashion, you can show that this is parallel to this, and then you can simply apply congruency rule and state that all the four triangles are congruent to each other. Since these two are midpoint, so we can also conclude EF is parallel to AD, parallel to DB, correct? And also for the third part, which is TE, is parallel to AF and FC, all by the midpoint theorem, correct? So this question was really easy but a tricky. L, M, N are three parallel lines bisected by traversal P and Q such that L, M, N cut off equal intercepts AB and BC, okay, on P. Show that L, M, N cut off equal intercept DE and EF on Q also. Okay, just try it out again. Since we are reading midpoint theorem, so it's obvious that midpoint would be applicable. We have given that this line and this line are equal, that means AB is equal to BC. Okay, so we'll write it down. Also, we know that M is parallel to N, all three parallel lines, which implies by midpoint theorem that AG is equal to GF. Because we have already learned that by midpoint theorems converse to that if the line intersects midpoint at one side and parallel to other side, then it also intersects the midpoint of third side. So this both are equal. Now, this is given to us and we know that M is parallel to L. So by this we know that D is equal to EF. Again the same theorem. Hence proved. Correct? Okay. Now we'll finish this up and in the next part we would be just quickly revising all the concepts we have learned. Thank you so much for attending the lecture.